Hello. So today I want to discuss about a problem that appeared in CMI entrance exam 2021. It's a geometry based problem, mainly a bit of construction based also. It's a different type of problem. So let's see. Here we have to construct a triangle ABC such that angle A is 20.21 degree. Side AB has length 1 and side BC has length x, and x can be varied, like x is any positive real number. So for a fixed value of x, we define n of x to be the number of pairwise non-congruent triangles with the given properties. So what we have to do is to determine values of x for which n of x is 0, 1, 2 and 3, whether this is possible or not. Like whether there is a value of x such that there no possible triangles can be formed, exactly one non-congruent triangle can be formed, exactly two non-congruent triangles can be formed, and so on. So let's do this.
This video is sponsored by Chinta.com. Since 2010, Chinta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
Initially make the structure. How does this look like? So somehow I have a point A and this is B, and as like angle A is always 20.21 degrees, C should lie on this ray, and this ray makes an angle 20.21 degree with the line segment AB. This is 20.21 degree. So let's see the diagram. Somehow I have a point A and this is I have point B, and AB is of length 1. Now as angle A is always 20.21 degree, C should lie on a ray, and that ray makes angle 20.21 degree with the side AB. This angle is 20.21 degree. C should lie on this ray. Suppose for a point C, I get a value of x, and I need to determine, like for this x, how many possible triangles can be formed, non-congruent. Like for that x, how many? So like I have to determine point C such that BC equal to x and C also lies on this ray, and the possible triangles are non-congruent. For that, we just make a circle centered at P with radius x. This circle cuts this ray at exactly 2 points. Name this C1 and name this C2. So in both cases, BC1 equal to x and BC2 equal to x, and it's both two are our possible configurations. So in this case, we have two non-congruent triangles, so nx equal to 2 is possible. So based on this construction, we try to generalize these things. So in general, in any cases, I have this thing, one segment and one ray. Okay, this is P, and I will for a particular x, I will draw a circle centered at P of radius x, and I will see at how many points the circle cuts the ray, because to get a triangle, the point C must be on this thing. For that fixed x, side length BC should be x, so it should lie on this circle, and it also lies on the ray, so it should lie simultaneously on the ray and the circle. So those favorable points C are the intersection points of the circle and the ray. Now there are different values of x for which different things can occur. So in this case, this is N, this is P. Starting at B, like for x to be, we take x to be very small and make different concentric circles. Now see, for these circles, like for these small values of x, the circle doesn't intersect the ray. So for this possible values of x, my n of x is 0 because no triangle can be formed. in all these cases, these are my points C1, C2. Like I can never make the triangle that satisfies these properties because it doesn't lie on the line. And if it lies on the line, it doesn't lie on the circle. Now, what are the criteria of these values of x? So, when does it happen? My circle doesn't cut it. Like my circle, so my radius of the circle, like x, is smaller than the distance from B to that line, to that ray. This is A, this is B. So my radius x, it is smaller than this big perpendicular distance. What is this distance? I know AB is 1 and this angle is 20.21 degree. So this perpendicular distance is sine of 20.21 degree. So in this case, I see that if my x lies between 0 and sine of 20.21 degree, the radius is smaller than the perpendicular distance. So in this case, they have no intersection point. So for any such cases, for all this x, my n of x is just 0 because it doesn't reach the, because this radius values, it doesn't reach the perpendicular distance. And for any intersection, that like radius to be at least that much minimum. So for all these cases, my n of x is 0. So n of x is 0 is always possible. Now when n of x is 1, now I make radius of the circle bigger and bigger. So starting from here, I make it bigger and more bigger. So there comes a point where it just touches the side, touches the segment. And after that, any circle of bigger radius, it cuts the ray at exactly 2 points. Now when it cuts at exactly 1 point, for that x, I have n of x equal to 1 because there is only 1 point that lies both on the circle and the ray. So there is only one possible value of c and the triangle ABC is uniquely determined. So for that value of x, my n of x is exactly 1. What is that value of x? So my circle just touches the thing. So in that case, my x is just the perpendicular distance. So in that case, there's exactly one triangle and this is also a right angle triangle. So for x equal to sine of 20.21 degree, this circle touches the ray. So in that case, I have n of x equal to 1. And for any x greater than sine of 20.21 degree, what happens? If x is greater than sine of 20.21 degree, any circle whose radius is bigger than this, so it must cut it at 2 different points. As it cuts at 2 different points, I have 2 different possibilities of C. This is A, this is B. This can be C1, this can be C2. In both cases, I have BC1 and BC2 equal to X. So triangle ABC1 and triangle ABC2 are both two triangles having desired properties, and triangle ABC1 and triangle ABC2, they are not congruent. You can easily see that because triangle ABC2 is much bigger than it and triangle ABC1 is contained in it. So no triangle is congruent to any triangle contained inside because their sizes are different. You can easily guess that. So for any x greater than sine of 20.21 degree, in that case my n of x is exactly 2. And n of x can never be 3 because a circle and a line, maybe here is a ray, whatever, a circle and a line, they can never intersect at 3 points because a circle is a quadratic and line is a linear equation. So the intersection point, the equation you get, it's a quadratic equation. Like it's a quadratic polynomial, so it can have at most 2 roots. So a circle and a line can intersect at most 2 points. So n of x greater than or equal to 3 is not possible. Because for that to happen, the circle must intersect the ray at 3 defined points, and it is never possible. So what we can conclude, n of x equal to 0 is possible. For this, we have 0x less than sine 20.21 degree, One is also possible, that is x equal to sine 20.21 degree and x greater than sine 20.21 degree for nx equal to 2. And nx equal to 3 is not possible. So this is true, this is true, this is true, and this statement is false. And we are done. This solves the problem.
Chinta programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Chinta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Chinta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit chinta.com.